Alright guys, so today we're going to be talking about the Friedel-Crafts Alkylation reaction, and this is an aromatic-based reaction that uses an R3CX patterned reagent over aluminum trichloride, or AlCl3, and what we get out of here is we attach a group that's probably going to be an alkyl-based group to our benzene ring. And so just to explain a little bit what the R3CX reagent is, it is a generalized pattern or formula for what our reagents are going to look like, in which we have a carbon, and then we have this R3, which represents the rest of the molecule that is attached to our carbon. And then we have an X, which represents the halogen. Now, since we're using aluminum trichloride, it's most likely reasonable to assume that we'll use chlorine in this reaction because it works best in our mechanism. So here is the mechanism as follows. So first, we are going to prepare our electrophile, or the molecule that our benzene ring is going to attack. And this is something common we see in a lot of aromatic reactions. So first, we'll bring out our R3CX, and I'll just write R's for the rest of our molecule, but for the X, I'm going to replace it with chlorine because we're going to be using aluminum trichloride here. And what's going to happen is that this chlorine has 3 lone pairs, and it's going to attack our aluminum. And so what we get is our R3C, and then we have our chlorine here that is bonded to our aluminum, and the chlorine has only 2 lone pairs, so it'll have a positive charge, and the aluminum will have a negative charge. So now what happens is that this bond in between the carbon and the chlorine will break, and we'll move those electrons onto the chlorine. And so what we get is our carbon here that only has the 3 R groups attached to it, and therefore has a positive charge, which means we have formed our carbocation, and then we have our AlCl4, because remember, there's 4 chlorines attached to the aluminum, and this will still have a negative charge. And so now what's going to happen is that we are going to bring in our benzene ring, and we will attack this carbocation. So I'm just going to move this down here. So I'll draw in our carbocation again, which is tertiary, and then I will bring in our benzene ring. And one of those double bonds is going to attack the carbon. And so now what we get is our benzene ring, and then we have our 2 double bonds there, and then we have our Cr3 and our hydrogens, and so we have a carbocation there. So now what's going to happen is that we are going to actually reuse our AlCl4, and we're going to use the chlorine to grab the hydrogen. And so what we do is this bond right here, we draw an arrow pointing towards the hydrogen we want to grab, and this double bond collapses onto our ring. And so what we get is our finished end product with our Cr3 here. And then we have 2 end products that are pretty important to remember, because one of them will be used to help us do the reaction again. And so that will be our hydrochloric acid, and then we'll also have our aluminum trichloride again, meaning that we can do the reaction again and reproduce what we've just done here. So this is the Friedel-Crafts alkylation reaction. Once again, it's pretty important if you want to add an alkyl group to your benzene ring, and then from there you can add other substituents, but this is the best way to do it if you're trying to form a carbon-carbon bond that has 3 groups to it. So I hope this helps. Have fun with it, and I'll see you guys in the next video.